Students. Yesterday we have seen the different types of fundamental units and the derived units. Now we are going to see what the scientists of different countries before 1971 did. Okay, so let's begin with our lecture. So the first thing, the scientists of different countries, what they used before SI unit were the MK system. So MK system, they used the MK so always it will be length, mass, and time. Okay, M stands for meter, K is for kilogram, and S stands for second. Then CGS, it is centimeter, centimeter, gram, and second. Then FPS system stands for foot, pound, and second. Okay. In 1971, in Paris, they held a conference for international system of units, and then came the existence of SI system. So SI system is what? It is internationally accepted system of units. Okay. So before writing the SI systems, some rules should be followed. They are: first one, always the units shall not be in plural. Example, 5 kg, not as 5 kgs. Okay, this is wrong. So only because always the magnitude is written 5 times of kg it is. So not 5 kgs. Then next, whenever we write a unit, it should start from small letter. Example, for meter, M. And if the unit is by a name of a person, then it must be written it must be written in capital letter, and name in small letter. Okay, so these are some more rules will be there to be followed. So now we let us take only three rules which are very important. Now let us find out the significant figures. So let us do the significant figures or digits. Okay. So now for example 0.001. So how many significant figures are there? There are, so 0.001, it has one significant figure. Okay. Then if the number is 1200, so these two zeros are not significant, hence it has two significant figures. Then if there is a number 1200.1, then it has five significant figures. Then for example, if it is a number 010, so it has three significant figures. So in such a manner, we have to write the significant figures. So that means here, if the zeros are after a non-zero number and there is no decimal point, then it does not have any significance. Hence, it has only two significant figures. Here you can see to the left hand side of 1 there are only zeros with a decimal point. Here these zeros does not have any significance. Only one is the significant figure. Here, the zeros are between non-zero numbers, hence 0 is also considered as the significant figures, hence we have five significant figures. Here also the same thing, 0 is in between a non-zero number, hence the significant figure is 3. So like that you have to determine the significant figures. Thank you for now. Let us do in another class. We will finish this chapter, that is the units and measurement. Thank you. Hello students. So I'm back here with a new video. Hope you are understanding my videos and following my videos. Please, if you have any doubts, you can ask me in the comments and let me solve your problems. And also it will be a pleasure of mine to solve your problems and come to your rescue when you have some doubts regarding the subject. It may be any chapter. Okay. First, the 11th and 12th, both the chapters, any chapters you can ask the doubts in physics. Okay, because I am your, as you know, I'm your physics wali madam. So like, share, subscribe to my channel, and let's begin. So in the previous video we had discussed about the significant figures. So now I'm going to tell you the rules followed to write the significant figures. Okay, so let us begin with, I will write the heading. Take your notebook and pen. Don't miss any point. Rules to write significant digits. Okay, so let us see the first one. All the non-zero digits are significant. So first of all the non-zero digits, the rule is all the non-zero numbers are significant. Okay. The second one, all the zeros between the two non-zero digits are significant, irrespective of the decimal point. All the zeros between two non-zero two non-zero numbers are significant, irrespective of the decimal point. Okay, so for example, 23.01. So 0 is in between the non-zero numbers. So here the significant figures will be 4 significant figures, or you can also write it as significant digits. Okay, then the third rule, if the number is less than 1, the zeros to the right of the decimal point and to the left, but to the left of the first non-zero digit are not significant. If the number is less than 1, the zeros to the right of the decimal point right of the decimal point, but to the left of the first non-zero digit are not significant. Okay, so these are three rules. We have two more rules. Fourth rule is the zeros at the end end of a number without decimal point decimal point I will do it like this because I can't write properly without the decimal point are not significant. Fifth one is the zeros at the end of a number with a decimal point are significant. The zeros at the end of a number with a decimal point are significant. So example I will give you. So here the fourth one, the zeros at the end of a number without decimal point. Suppose it is 2400. So here there is no decimal point. Okay. So here the significant figure is 2. And how many ever it may be, 2000 or 2400, 24,000 or 2,40,000, anyhow how much the big number it is, but if there are zeros without a decimal point, then it will be only two significant figure. Then if we place for the fifth point example, let us see. Now if I place a point here, okay, so if I place a point here and write the so here if I place a point here and write here 0 0, then there will be 1 2 3 4 5 6 7 8 8 significant figures. Okay, so this is a magic and this is the trick of the significant figures. So this is the fourth point, answer to the fourth point, and this is the answer to the fifth point. So suppose one more example I will give you. 1000.00. So here how many digits, significant figures? There are 6 significant figures. Okay, I hope you understood. So let us proceed to the next, that is we will see the important topic of this lesson chapter, that is the units and the measurement. So before going to the dimensions, let us see the rounding of the significant figures, rounding off and writing the significant figure. Suppose if it is 12.45 and if it is asked to round off to three significant figures. Now we have the original number, we have 4 significant figures. Okay, but the question is round off to 3 and write the significant figure. So here as there is a 5 here, we can carry 1 to the third digit, that is 4, and we can omit the 5 number, that is we can write this as 12.5. 5. And now we can write it as 3 significant figure. Okay, so suppose if it was 12.43 and round off to 3 significant figures. So originally it is 4 significant figure. Then we can omit this one because it is less than 5. So we can just write it as 12.4. So we have now 3 significant figures. Okay. Another example I will give you. So suppose it is 236.74. So here how many significant figures are there? There are 5 significant figures. Okay. Now the question is asked like find the round off to 4 significant figures or 3 significant. Let us find out for 4 significant figures. So as 4 is the least one, it is lesser than 5. So we can omit this one 4 and we can get to up to 4 significant figure, that is 236.7. So it will be 4 significant figure. Now if it is asked for 3 significant figure, we can as 7, we'll omit this 4 and we can take 7, that is it is greater than 5. We can carry 1 to the 6 and now we can write it as 237 and here it is 3 significant figure. So this is how we can round off and write the significant figures. So let us go to the next topic of this chapter, that is dimensions. So dimensions. So dimensions are nothing but, as we have done the base quantities, base units, so that units we have to write within the bracket. Some we will use the units and some we will give the notations of uh, the physical quantities itself. So for example, length. So length, directly we will take the dimensions of length as with always it is written in a square bracket, capital L. Okay, and mass M, capital M. We will not take here kg or meter. We will avoid that and we'll just take the first letter of the physical quantity, that is L and M. So don't confuse here. So this is the rule. This is how we should take it. Then time, capital T within the square bracket. Then current, electric current, will not take here I, we will or C. We are going to take the unit, capital A, because already it is capital A. We'll take the capital A. Then temperature, it is taken as Kelvin, capital K. Okay. Then luminous intensity, we will take it as CD, because we cannot take L because already we have taken for length L. That's why we'll take it as CD. Then the amount of substance, mole within the square bracket, MOL. Okay. So these are the dimensions we use in the units and measurement chapter. capital L for length, capital M for mass, time for time, capital T, then current, capital A, temperature K, capital K, then luminous intensity CD, then amount of substance mole. Okay, so here this is how you have to write the dimensions. So let us start the dimensions. So for example, now force. I want to write the dimension for force. So force formula is m into A, that is m is for mass and A is the acceleration due to gravity. So m, capital M will write m, and A is meter per second. So meter is length and second square, that is T raised to minus 2. So like this we are going to write the force. Now let us see for velocity. That is displacement by time. So here there is no mass. If there is no mass, we will write it as m naught, or simply you can omit it. But if it is asked all the three, then write m naught, L, T raised to minus 1. L is for the displacement, that is measured in meter only. Then time is per time. Okay. Okay. Next we will see the work. Sorry. For work, it is force into displacement. So already we got the force here, and displacement is length. So first I will write the force, ml t raised to minus 2 into displacement is L. So we'll combine these two now. So L raised to 1, here is L raised to 1, so it will be 1 plus 1 is 2. So it is m L square t raised to minus 2. Okay. Next we'll write angular momentum. So that is L is equal to P into R. So P is what? It is m into V into R. So m is capital M. For velocity is L t raised to minus 1 into again L. So this is m L square t raised to minus 1. Right? Okay. Now let us see the kinetic energy. Half mv square. So half we will not consider because it is a constant. So dimensions cannot be taken for constants and the trigonometric functions. So here m is capital M and v square is, that is the velocity, that is L square t raised to minus 2. So like this you have to write the dimensions of a physical quantity. I hope you have understood. So let us go to the other section. So now let us know what is the difference between a dimensional formula and a dimensional equation. So here dimensional formula. Okay, dimensional formula is expressing a physical quantity in terms of dimensions only. So if velocity asked, then we can take directly the, don't take the equal value, is equal to, you should not take, just you write the dimensional formula m naught L t raised to minus 1. So this is the dimensional formula. And dimensional equation is, I will show you. So there should be a LHS and RHS in the equation. So velocity is equal to m naught L t raised to minus 1. So this is the equation. So here, so I hope you have understood what is the difference between a dimensional formula and the dimensional equation. Formula is just, you have to write the equation, formula of the velocity, then remove the dimensions of it, and equation is, you have to write the LHS as well as the RHS. So now we'll see the dimensional analysis. It is also called the dimensional analysis and its application. So heading will write dimension analysis and its application. So here, first of all, the first one is convert the unit of a physical quantity from one system to another. So it is convert a physical quantity, unit of a physical quantity physical quantity from one system to another. Okay. So this is like, so let us see. So let us see how to convert the system from one form to another. So let us take force example. So in SI system, force is taken in terms of Newton and CGS as dyne. So we'll take the values, the dimensions here as M2, M1, M1, L1, T1, T is same, and for dyne we will take it as M2, L2, T. Okay. So here one Newton upon one dyne you have to write, that is equal to, so the force equation is ml t raised to minus 2, so m2 l2 t raised to minus 2 upon m1 l1 t raised to minus 2 So m2, this both will get cancelled. So because they are same, m2 by m1, let us take in one single bracket, and this as L2 upon L1. Okay. So here mass is in 1 kilogram upon 1 gram into 1 meter upon 1 centimeter. So now here this kilogram and meter will take in CGS only. So this is 1000 gram upon 1 gram into 100. So 1 meter is 100 centimeter. 100 centimeter by 1 centimeter. So units will cancel out. So it is 10 to the power of 3 into 10 to the power of 2. So it will be 10 to the power of 5. So 1 Newton is equal to, so this denominator will take here 10 to the power of 5 dyne. So this is how we have to write conversion of the unit from one form to another form. So we have converted here from the SI system to CGS system. Hope you have understood this. Let us go to the second application, that is checking the correction of the equation. Correctness of the equation. So here let us take one equation, V is equal to U plus AT, simple equation. I will take the mechanical equation. So each one of the each one of the physical quantity we have to solve. V is equal to the dimensions we have to take. V is L t raised to minus 1. So we got V value. Then U is what? It is the initial velocity. So it will be same L t raised to minus 1. Then AT, A into T. So A is what? L t raised to minus 2 into T. So again it will be L t raised to minus 2 and plus 1, it is minus 1. So all are equal, hence the equation is dimensionally correct. So we have to solve in this form. One other example I will give for correctness. So let us take S is equal to ut plus half at square. So the constant values we cannot take the dimension. So let us take first S is L, ut is L t raised to minus 1 into T. So it will be L only. Then at square is equal to L t raised to minus 2 into T square. Again it will be L. So all are equal. L, we got all the equal dimensions. So therefore it is dimensionally correct. So this is how we have to check the correctness of the equation. So next third one, let us see. Deriving a correct relation. Third application it is deriving a correct relation between the different physical quantities. Between the different physical quantities. So let us take the example of a simple pendulum where we'll take the time period of the oscillation of the simple pendulum, which is proportional to the mass. Let us take the power as x, then length raised to y, and g raised to z. So we have to derive the relations between these. So let us take the t as k m raised to x, l raised to y, g raised to z. So here let us take t as the dimension of time as m naught, l naught, t raised to 1. So for time being we'll not consider k value. Afterwards we can insert it. So m is the mass. So it is m m raised to x, l is length, l raised to y, and g is acceleration due to gravity. So acceleration dimension we will take it as l t raised to minus 2 raised to z. So this is x value will equate the powers here. So m raised to x, so none of them having in the RHS we don't have any m value. So x is equated to the LHS, that is m raised to 0. X is equal to 0. Then length you can see here l raised to y and l raised to z. So we'll take the powers only. Y plus z is equal to here l is equal to 0. Okay, then time here it is minus 2z, minus 2z is equal to here time is 1. So first of all we will take the z value, we'll find the z value. Z is equal to minus 1 upon 2. So now x we got and z we got. We can substitute here in this equation. Y minus half equal to 0. So y is equal to half. So experimentally k value is 2 pi because oscillation, for complete oscillation in the simple pendulum it will make 2 pi oscillation, that is full completely if we take it will be 2 pi. So it is 2 pi. So therefore t is equal to 2 pi. So L value was, so m is 0, m will not take m. So L value is L raised to y because it is half. So we'll take under root by L upon z value we got it as minus half. So that is g is g raised to minus half. So it will be in the denominator but under the root. So the time period for a simple pendulum is, we have got the equation as t equal to 2 pi under root of L upon G. Hope you have understood the topic. So this comes to the end of the units and measurement chapter. Then in the next session, we will take the motion in straight line chapter. Thank you. Bye bye.
Hello, my dear students. Welcome to my channel, that is Physics Poly Madam. So, I think you have seen the previous chapter, that is units and measurement. I hope you have understood. So, if you have any queries, you can ask me. Then, we will talk about today the second chapter of your 11th class, part 1 book, that is Motion in Straight Line. So, if you are new to my channel, then please go through the first chapter Then you can start the second chapter, that is motion in straight line. Okay. Please subscribe my channel, comment in the channel, and you can share to your friends also. So let us begin. So here, motion in straight line. So the motion in straight line, it is mainly, it comes under the subject called mechanics. Mechanics is divided into two parts, that is statics and statics is the branch of physics which deals with the object at rest, and another one is the dynamics. Dynamics deals with the objects which are in motion, the study of objects in motion. Again, dynamics is divided into two, that is kinematics and kinetics. Kinetics is the motion of the object on in which we do not take the path which it has covered without taking the account of its path. That is known as kinematics. Without taking into account the path. Then here in kinetics, it is the cause is known. Cause is known. Okay. So this is the basic or the introduction of the motion in straight line. So let us go to the next slide. So wherein we see some of the definitions in this chapter. First one, let us see what is a rigid body. A rigid body is said to be a body if it has definite shape and size. First of all, it is a body which has definite shape and size and does not change its shape and size when the deforming forces are applied on it. So such type of bodies are ideal, hence such bodies are known as the rigid body. Okay. Then what is a particle? In physics, you can see if there is a star or if there is a planet and the planet revolves around the sun. So the distance covered by a planet is greater than the dimension of the planet itself or the diameter of the planet itself. Hence, we call such objects as a particle. A particle is a point mass. So now this planet is also known as a point mass or a particle. So comparing the distance, how much it has traveled, its dimension is very negligible. Hence we call that as a point mass or a particle. Then what is the motion? An object is said to be in motion if it changes its position with respect to the time and surrounding. Okay. So whenever the body changes its position from one point to another point with respect to its surrounding. So for example, if you are leaving your home, this is your home, at 9 a.m. you leave your home, okay, and come to the college or your school at 9:15 or 9:20 a.m. So your the position of yourself has changed. So your body is moving from one point to another point, and the surrounding also. So the surrounding with your in your house to the surrounding with the school has been changed, and the time also has been changed. So 20 minutes you take to move from your home to your school. So that's why it is called as motion. And let us see what is rest. So rest is the opposite of motion. Rest is a body is said to be in rest if it does not change its position with respect to time and surroundings. So suppose if a lamp post will be there only, okay, till the if it is in the morning also it will be there only, in the night also it will be there itself, okay, and the surrounding will be not also changing because it is situated on the earth. Earth is the frame of reference for the lamp post. Hence here rest is the body is at rest, it does not change its position, okay. So when you are sleeping on the bed, you are at rest, you are not moving, your body is not moving, okay. So that even though the time is changing, the surrounding is not changing, so you are at rest. Hence here it should be with respect to passage of time, respect to time, with respect to surrounding, but even the time passes, it is known as rest. Okay, let us go to the next slide. Let us see now what is frame of reference. So frame of reference is nothing but the coordinates. Okay, coordinates. So here we have three coordinate system. So let us take this as x-axis, y-axis and z-axis. So these are the coordinates. So if there is a particle in xy plane, so how much distance away the point is from x-axis and how much distance away the body is from the y-axis. Now xy becomes the frame of reference for the particle. Let us take the particle as P, right? So now we want if a bird is flying, okay? If the bird is flying, so what will be the frame of reference for this? So something, a building it may be, or a tree from which it is flying. So that becomes the frame of reference. So there are three frames of reference: one dimensional frame of reference, two dimension frame of reference, third is three dimension. Okay, so there are three types of frames of reference: one dimension, two dimension and three dimension. One dimension is a body which moves along a straight line, either along x-axis, along y-axis, or along z-axis. Okay, any one of the coordinate. Such motion or such frame of reference is known as the one dimension frame of reference. If the body is in between any two frames of reference, for example a plane, a projectile motion has two dimensions. Circular motion has a two dimensions. And three dimension is a body which is moving in space. So for example, the flight of the bird, the aeroplane moving in the sky. So such examples are known as a three-dimensional frame of reference. Okay, and another one frame of reference, inertial frame of reference and non-inertial frame of reference. Inertial frame of reference is a reference which is stationary or static. Non-inertial is a frame of reference which which will be changing. So here, inertial frame of reference is the earth, and non-inertial frame of reference is a vehicle. So vehicle will not be stationary; it will be moving. So such frames of reference is known as the inertial and non-inertial frame of reference. So I hope you have followed till here. Then let us see in the next class. We'll continue the chapter. Thank you. Bye bye. Please subscribe to my channel if you like it, and if you have any queries or doubts, you can ask. You're free to ask. Thank you. Bye bye. Hello, my dear students. Welcome back to my channel, that is Physics Wali Madam, that you know. So, if you have not seen my previous videos, please go and watch my previous videos. And the second chapter I have already started, that is motion in straight line. So here, and first and foremost, I want to thank you, all of you, those who have subscribed to my channel, liked and shared my videos. Thank you, one and all. So let us start today's video. So we'll see some of the motion of the rigid body, and we will see some of the definitions. I'll explain in brief some of the definitions which we come across in our mechanics subject. Okay, so let us start with the motion of a rigid body. So I told you in the previous video what is a rigid body. Rigid body is a body which have a definite shape and size. Okay, so now let us see what type of motions will a rigid body have. Always the rigid body will have a translatory motion and a rotatory motion. So let us see what is the translatory motion. So translatory motion are the motion in which in the body all the particles move in a same direction. They move in a particular direction when an external force is applied on the body. So here you can see the car is moving in a direction. Not only the car, the body of the car, the wheels, all are moving in a particular direction. Now in the second picture you can see an apple falling from the tree. So entirely the apple is falling in the one straight direction. The train moving, okay, and a football which is kicked, it moves in the forward direction. So the bodies, the body which will be moving in a particular direction, that is known as a translatory motion. And let us see a rotatory motion. What is rotatory motion means? In a rotatory motion, always the center line is known as the axial line. The particles in the axial line will be fixed, and the particles which are in the neighboring side of the axial line, they will be rotating in a circular direction with different radius. Okay, so and they will have a rotatory trajectory. So such type of motion is known as a rotatory motion. You can see the example of a torque, a giant wheel, okay, then the fan of the helicopter, and the earth moving along its own axis. Okay, so these are the examples for rotatory motion. So translatory is the all the particles in that object will have a forward direction or in a particular direction, but in a rotatory the center axis will be fixed. All the particles in the center axis will be fixed, and the neighboring particles will have a circulatory motion. So this is known as this is the difference between a translatory motion and the rotatory motion. So let us go to the second slide. So let us see I will give the definition of the translatory motion. So you can take your notebook and write it down. So translatory motion is a motion in which all the particles have in the or have a particular direction of motion, or we can write as a rigid body is said to have translatory motion when it moves such that all the particles of the body have the same direction. In a translatory, so I will type it. In a translatory motion, all the particles move in a same direction, same direction, and in rotatory motion, all the particles in the axial line will be fixed and the nearby atoms, nearby particles will move in a circulatory motion. So this is the difference between a translatory and circulatory motion. Let us go to the next slide. So let us see what is position, path length, and the position, path length, and the displacement of the particle. So now you can see the figure in the next slide. So position means, so here O is in the position 0 on the number line, Q is in the position 3, P is in the position 5, R is in the position -2, and S is in the position -4. And this is position. That means the location of a particle in a particular direction is known as the position of the particle. Then what is path length? Path length is the total length of the body. It is the total length of the body. So that is, if the body moves from O to Q, so it is having 3 meters. So suppose if it is measured in meters, 3 meters. Again from Q to P, so we'll add 3 plus 5. So 3 plus 2. So this is total distance. So that is path length. Then displacement is, so if the particle moves from 3 to 0 to 5, and again comes back to 3. So we'll take it minus because it is going in the opposite direction. Hence, this is the difference between the position, path length, and the displacement. So we can see the definitions clearly. The position of the object is measured with reference to conveniently chosen origin. Path length is the distance moved by the object from one position to another is called path length. Displacement is defined as the change in position of the object in a particular direction. Okay, so let us move on to our next one, velocity. So what is velocity? Velocity is nothing but it is the displacement by time taken. Displacement by time taken. So if we take instantaneous velocity, in this velocity we have average velocity and instantaneous velocity. Average velocity is delta v by delta t, and instantaneous is dv by dt, or we can have the limiting value, limit of delta t tends to 0, delta v by delta t, which is given by dv by dt. Okay, so similarly we have for acceleration, or let us take for speed. So speed is a scalar quantity. It is defined as distance upon time. So average, it is also denoted by v. So that is dx by dt. So sorry. Here velocity is d delta x by delta x by delta t dx by dt, and here also delta x, that is displacement, okay. So my mistake, I apologize. So here again instantaneous speed we can take it as limit of delta t tends to 0, the delta x upon delta t, which is equal to dx upon dt. And similarly we can take for acceleration. Acceleration is the rate of change of velocity dv by dt. It is given by, again, average acceleration is dv by dt. Instantaneous acceleration is limit delta t tends to 0 dv by dt. So its SI unit is meter per second, meter per second square, and speed is SI unit is meter per second, and velocity SI unit is meter per second. Hope you have understood. Please, if you have any queries, you can ask me. And please subscribe to my channel. Till then, bye bye. Thank you.